Hi guys, welcome to my new video. We'll be discussing about the humanoid robots in the world. It's a new video assignment of artificial intelligence and machine learning. If we go to the agenda of today's videos, there will be introduction of the humanoid robots, which contains the definition and proposed introduction of topic, and the proposed by means it will discuss about the people who started the innovative ideas of proposing the robotic arms and humanoid robots and robotic automata. And the next topic is planning and control. It will decide what are the plannings and control have been taken uh, to perform a operations of humanoid robots perfectly, and the apparatus that is needed is the next topic. It contains the actuators and sensors and the areas of growth which contains the users of the applications of humanoid robots and the challenges due to the preparation of humanoid robots in the current scenario. And finally we'll be discussing about the notable examples in the real world. If we go to the introduction, the definition part of the humanoid robots are: a humanoid robot is a type of robot that is designed to resemble mimic the physical characteristics and movements of human being. These robots are constructed within a body structure similar to that of a human, often with a head, torso, two arms, and two legs. They have facial expressions which allows for more natural human-like interactions. Key characteristics of humanoid robots include physical resemblance, bipedal locomotion, dexterity. If we come to the physical resemblance, humanoid robots are built to have physical appearance that resembles humans to varying degrees. This includes having a similar number of limbs and joints as well as head and face. If we come to the bipedal locomotion, many humanoid robots are designed to walk on two legs, similar to humans. This bipedal locomotion is a challenging aspect of the design. It requires stability and balance control. The next topic is proposed by information of the humanoid robots. The concept of humanoid robots has a long history and cannot be attributed to a single individual or inventor. Instead, it has evolved over time through the combination of many scientists and engineers and science fiction writers. Means it is not the credit is not given to a single individual or a person. The timeline of uh, the timeline of every development will be attributed to every individual who has contributed the proposals of many scientists, engineers, and science fiction writers. Here are some key milestones and contributors in the development of the concept of humanoid robots. Ancient mythology and legends. The idea of artificial beings resembling humans date back to ancient mythology and folklore. Examples include the ancient Greek myth of Pygmalion, who sculpted a woman from ivory and brought her to life, and the Jewish legend of the god, a humanoid creature created from clay. It is actually a fiction. We previously discussed it. The contributions of science fiction writers also include in this contribution proposals. And the next important person is Leonardo da Vinci, the renowned Renaissance polymath. Leonardo da Vinci conceptualized and designed various mechanical devices, including humanoid automatons. His sketches and designs for humanoid machines demonstrate early interest in creating lifelike automata. He is a father of automata. If we come to the topic of planning and control, we'll be discussing the five types of plannings that is included in the humanoid robot. First is motion planning. Motion planning is a process of determining sequence of movements and joint configurations for the robot to achieve a specific goal in the context of humanoid robots. This includes planning the trajectory for walking, reaching, and other motions. This motion planning includes the basic operations like walking and identifying the specific objects and moving according to the situation, and it includes the algorithm like RRA, which defines rapidly exploring random trees, and A star are often used for motion planning. A star is A star algorithm is mainly used in this motion planning topic because uh, it is used for best first search. Means uh, it will dis- it will find the best way to travel between two nodes or 2 points by finding out the cost and heuristic values the the travel distance. The next planning topic is task planning. Task planning involves high level decision making to determine what task the robot should perform in a given scenario. For example, a task planner might decide that the robot should walk to a specific location, pick up an object, and then place it in another location. In this task planning, we'll use AVO star algorithm because in AVO star algorithm, along with the tracking, there will be a concept of backtracking, which helps the humanoid robot to find out the each and every neighboring node of a pickup or dropout locations. Path planning. Path planning focuses on finding a feasible path through the environmental to reach a goal while avoiding obstacles. This is particularly important for navigation and obstacle avoidance. This is the basic uh, planning method because if an obstacle is intended in the following way, a humanoid robot will face the issue of motion and confusion of moving here or there. So, by using the path planning operation, it can easily identify the obstacle within the certain limit of uh, view, and it can change its path by using the A star or AO star algorithm. AO star algorithm will mainly use because it will ignore the it will ignore the most it will actually make the path of robot efficient rather compare with A star algorithm. Trajectory planning. Trajectory planning defines the planned path by generating a sequence of waypoints and joint configuration that the robot should it follow to execute the path smoothly. Inverse kinematics. Inverse kinematics calculations are used to determine the joint angles or positions required to achieve a desired end effector or body part pose. This is crucial for positioning the limbs and hands accurately. If we come to the topic of control, low level control, feedback control, balance control, compliance control, and effect control. We'll be discussing a few topics in this control method, like low level control. Low level control involves the real time execution of motor command to regulate joint angles, torques, and forces. Controllers ensure that the robot's actuators respond appropriately to achieve the desired motions. This low level control will be depending upon the basic operations like robotic arm, which is recently developed by Boston Dynamics, which is famous of doing this pick up and drop things efficient manner. So the for a robotic arm, low level control is sufficient. Feedback control systems uses sensor data such as information accelerometer, gyroscopes to continuously adjust the robot's movements and maintain stability and accuracy. This is considered as high level control because for every movement and force applied to the particular object, it is calculating some sensor data such as information from accelerometers and gyroscope, the amount of force and torque is applied to the particular object, and the reaction which is reaction which is expelled from the object in accordance with the robot. By using the feedback control, we can adjust the robotics movements and maintain stability and accuracy. Balance control. Maintaining balance is particularly challenging for humanoid robots due to their bipedal nature. Balance control algorithms continuously monitor the robot's posture and apply corrective actions to prevent falls. If we check the previous planning planning topic, the balance control will matches the same characteristics of its compliance control. Compliance control allows the robot to interact safely with the environment and humans by adjusting the stiffness of its joints. Compliance control can be easily important in tasks involving in physical contact. These are the notable humanoid robots. Asimo, it is developed by Honda Dynamics. Atlas, this is the recent innovation by Boston Dynamics. In this low-level control and feedback control is used. Pepper Soft and the Pepper Software Robotics. It is a humanoid robot. Sophia Hansen Robotics. It is developed by Korean agency. It is a high-level robot in the modern life era. Mara. It is developed by German Aerospace. It is also depending on the low-level control, like picking up and dropping the objects using the robotic arm. ICUB. It is developed by European Robotic Agency. HRP4C. It is developed in Japan Institute. Plan for product launch. Plan for product launch includes 5 steps: planning, marketing, design, strategy, launch. By following these 5 steps, we can easily increase the production of humanoid robots for the modern era of future. To increase the demand in the demand of humanoid robots, we should be uh, tick the boxes which is not efficient in the recent times. Like we should focus on some areas like research and development, education, assistance and care, healthcare, customer service. So by focusing on these areas, we can actually replace the humans with the humanoid robots. Like humanoid robots are valuable tools for researching various aspects of robots, artificial intelligence, and humanoid robot interaction. They can be used to test algorithms, study human behaviors, and advance our understanding of both robotics and human cognition. Education. Humanoid robots are used in educational settings to teach robotics and programming concepts. Assistance and care. Humanoid robots can assist people with disabilities or the elderly in daily tasks such as fetching items, providing reminders, or offering physical support. Healthcare. In healthcare settings, humanoid robots can be used for patient monitoring, assistance in rehabilitation exercises, and even performing certain medical procedures under the guidance of healthcare professionals. Customer service. Humanoid robots can be deployed in retail stores, hotels, and other service industries to provide information guide customers, and assist with tasks such as check-ins and checkouts. To reach the customer requirements, we should get there by following these steps: consumer demand, investment and funding, and collaborative robots. As consumer awareness of humanoid robots grows, there is a potential market for personal assistant robots and companion robots. These robots could assist with household chores, provide entertainment, and enhance daily life. Investment and funding. The robotics industry has received significant investment from both public and private sectors, supporting research and development efforts. Investment in startups and establishment companies drives innovation and market. Collaborative robots. Collaborative humanoid robots, often referred to as cobots, are designed to work alongside humans in shared spaces. They offer the potential to improve the productivity and safety. If we come to the topic of challenges means disadvantages or aspects which is negative to the humanoid robot is the main thing is cost. Building and developing humanoid robots can be expensive. The advanced technology, materials, and research required for the construction can result in high production and maintenance costs. Complexity. Humanoid robots are inherently complex machines. Their mechanical design, control systems, and software require advanced engineering and are prone to mechanical failures and software glitches. Limited mobility. Achieving stable bipedal locomotion is a significant challenge for humanoid robots. Their mobility is often slower and less stable than that of wheel or tracker robots, making them less suitable for certain applications. Power consumption. Humanoid robots require a significant amount of power to operate a basic operation, especially those with advanced sensors, motors, and control systems. This can limit the battery life and require frequent recharging or connection to power sources. Maintenance and repairs. Humanoid robots, like any complex machinery, require regular maintenance and repairs. Fixing mechanical issues or software bugs can be time consuming and costly. And the major impact to the human life will be unemployment. By building these humanoid robots, it can replace a human not in present situation by developing the innovations and contributions in the future aspects of life can replace the human leads to unemployment of the human beings and leads to scarcity of money between them. So these are the topics which we have been discussed for since start of my video and completing my agenda. So thank you for cooperating for me with me. Thank you.